Hello guys, this is Saddam Leonardo Cap and today we are going to discuss about tachyon dark energy. Now this discussion is based on our recent research paper. The title of the study is Dynamical System Analysis of Tachyon Dark Energy Model from a New Perspective. So in this video, I will first introduce you what is tachyon field, as well as we have give you the brief idea about how we are carrying the dynamics of this field with the help of dynamical system analysis. So let's get started. Now here is the picture which denotes that what is the contribution of different component in the universe. From the observation, we understand that the dark energy is about 68%, which is dominant, and we have the dark matter which is around 27%, and ordinary matter which is 5%, and this ordinary matter in which all the things that we are made up of. Now this dark matter and dark energy, why they are dark? Because they are not interacting with light, so they have some gravitational signature. Apart from the gravitational signature, we don't know many things about this dark matter and dark energy. Now, how we have arrived this thing? So first of all, to understand what is the component of the universe, we have to first use this kind of model. This is the standard model in cosmology. So this is lambda CDM model. Lambda denotes the dark energy. So it has some constant dark energy, which pressure is P is equal to minus of rho. So pressure is negative. Energy density of this dark matter is positive. And on the other hand, the pressure of dark matter is 0, as well as the ordinary matter has 0 pressure. Okay. So this cold dark matter, CD means that cold dark matter. So cold dark matter is the other 32%. And lambda corresponds to 68%. Now, to explain the dark energy, there was lambda CDM cosmology. Beside that, we have quintessence. We have already talked about the quintessence in my other videos, and also we have talked about the K-essence. Okay, so in the quintessence, we have a simple scalar field in which we can have the dynamical perspective of the dark energy. On the other hand, K-essence have the non-canonical feature where the leading term, that is X, can exhibit the dark energy kind of scenario. So to understand more about this thing, you can check out those videos. Now, before going to understand about the tachyon field, for any kind of field, like either it is quintessence or K-essence, you require to have some kind of potential. Okay, so in this case also you have to specify some kind of potential, and here are some known potentials which people have already studied, like 1 by power law type of potential, 1 by phi square, exponential potentials like e to the power of minus phi, e to the power minus phi square. On the other hand, you have the cos hyperbolic of phi. Okay, so I'm coming to the point that how this tachyon field behaving on different potential. But before that, when we are looking at the action or the structure of this field, this structure of the field is not like quintessence. Like it does not have the d mu phi and d mu phi. It is under the square root of 1 plus d mu phi and d mu phi. Now, because of the square root, this field phi can take any value from minus infinity to infinity. But on the other hand, this kinetic part, because when you just resolve it, then you will get 1 minus phi dot square. Okay, so this is the kinetic energy of the field. Now this kinetic energy of the field have the upper and lower limit, which is plus minus 1. Okay, so because of this kind of characteristic, it is acting like a dBi field, means the Dirac bond in field kind of field. Now the origination of the field is coming from the decay of some strings, some D-brane strings, and this action has been identified in the string theory. And around 2000, Anjan Ananda who has shown that if you are studying the tachyon field, then around the late time it can behave like the pressureless classical dust. Okay, so if you have, suppose you have only the tachyon field, then it can the D-branes can decay, and the characteristic of this field is kind of pressureless kind of behavior. So when people have shown this thing that, okay, so I think that this tachyon field is behaving like a dark matter. So now people have started to study in the context of cosmology. Now to do that, they have proposed that, okay, let us study with respect to 1 by phi and 1 by phi square. So for 1 by phi, they understood that it can behave like, so 1 by phi and e to the minus phi, it is behaving as an inflation kind of field during the early time of epoch. As we are understanding that after the Big Bang, the universe has gone through the rapid accelerating expansion, and this expansion was for up to 10 to the minus 31 seconds. Hence this era is known as inflation. Okay, so it has, the tachyon field has dual kind of behavior. And the late time, it can give you the pressureless kind of fluid or dust kind of solution. In the early time, it can behave like inflation. On the other hand, we know that after the inflation ends, there is a radiation era. So suppose that this field, any field phi, which is taking the inflation, after that it has to decay and generate the radiation field. But this cannot be, the generation of heating process or cannot be seen with the tachyon field. So it can give the dark matter kind of solution, but it cannot end the inflation or cannot generate the radiation kind of epoch. Therefore, it cannot be studied, it cannot be, used as a very standard model to study the inflation and so on. On the other hand, this potential also, exhibit the pressureless kind of scenario. But when people have studied this tachyon field with, by assumption that suppose there is a background fluid, and this background fluid is just like dark matter, because we have dark energy in dark matter. So consider that I'm studying this field with dark matter, okay, the pressureless fluid with the presence of 1 by phi square e to the minus phi, or to take any potential, then the tachyon field is giving the accelerating kind of solution. And from this, people have shown that, yeah, tachyon can, resembles the dark energy kind of behavior. It is basically giving you the accelerating solution, okay. So therefore, the action of the system that we want to study, that the dark energy is behaving like dark, tachyon field is behaving like dark energy. Therefore, this tachyon field is coupled with the barotropic fluid whose pressure is 0 and minimally coupled with the gravity. So this is Einstein-Hilbert action. This R is Ricci scalar. On the other hand, G is the metric, and this is the determinant of G mu nu, and square root of minus G ensures that the square root is always positive. And again, you know that you have any kind of perfect fluid, so the energy moment inertia corresponds to this one is T mu nu, which is rho minus P and so on, okay. Now, if we are comparing this, because now it has the structure of square root, therefore it is no longer a canonical kind of field, it is now a non-canonical kind of structure. And this d mu phi is encapsulated in X, the way we have studied the K-essence, okay. So K-essence is also having some kind of term X, which is having the higher derivative term like phi dot square, okay. If you want to understand this action, we have to first varying the action with some kind of independent variables, like G mu nu is our independent variables, phi is the independent variable. So if I am going to vary this action, we are going to get some equation of motion. First of all, we are assuming that our universe is homogeneous and isotropic, and this homogeneous and isotropic can be understood from the FLRW metric, the Friedmann metric. And therefore, the field equation, by varying this action with respect to G mu nu, we will get the two equations. One is corresponds to the time equation, which is giving you the first Friedmann equation, and another is that corresponds to the spatial component, which will give you the time derivative of the Hubble parameter. The Hubble parameter is defined as the scale factor, this one. So it is a derivative of the scale factor, and this, what is the scale factor? The scale factor is the measurement of that how the universe is basically scaling up. Everything is scaling up. Okay, so it is bigger. So for an example, before you were using centimeter scale to measure the measure some distance, now you have to use the meter scale, and so on. So that is the meaning of scale. So it means that the scale is basically changing. Now this scale factor is only depend on the time. Now come to the second thing. If you are varying the action with respect to phi, then you will get the field equation corresponds to the phi. Now, if you will see these equations, these three equations, what you require is that you have to first define what is your potential, and corresponding to this potential, then you can find that what could be the solution of phi dot, and from there you can easily calculate the cosmological things like omega total, the equation of state. Now, equation of state is a very interesting quantity. Equation of state is telling you that how something is accelerating or not, and this can be found out by P total over rho total, okay. Because now here, why we have written P total by rho total? Because we have the field as well as the fluid, therefore it is come to as a P total. On the other hand, if you have only the field, then we can always write P phi over rho phi. Okay, so this is the equation of state of the field, and on the other hand, we have the equation of state of the fluid, that is P over rho, which we have already denoted here, that omega into rho of B. Now we have already assumed here that background fluid is pressureless, therefore the equation of state of the background fluid is 0. So 2s dot is equal to minus of phi dot square V over square root. Now this 3h square is proportional to the energy density of the field, therefore this is the energy density of the fluid, and as well as this is the energy density of the field. Okay, now if you divide this 3h square by whole thing, then what you will get, you will encounter that this is the critical density of the field and critical density of the fluid, and this will be equal to 1. Okay, so what we understand that if you want to study this whole scenario, whole dynamics, you have to first define what is your potential. Okay, now we have already seen that there are so many different classes of potential which exhibit different things. Okay, now e to the power minus phi, e to the power minus phi square cos hyperbolic of phi, they are coming in the picture from the string theory. On the other hand, this power law type of potential is we have invoked from phenomenological approach that we have already studied in case of quintessence, so we want to study. But besides this, there can be different amount of potential. So we have large, the pool of potential, but we don't know that which could be the favorable potential. On the other hand, you also understand that 1 by phi square e to the power minus phi e to the power minus phi square, they can give you the same dynamics in the late time cosmology. There is no any variation. They can always produce the accelerating thing. Therefore, the potential can be anything, and the observational signature will remain same. So from observations, we cannot distinguish that which could be the greater potential. And obviously if you are incorporating different potentials, then we have we can have more potentials. Therefore the technique to introduce, first assume some form of potential, is not a very amazing technique. So what we can do, first of all, we are going to convert everything in terms of dynamical perspective. What is the meaning of it? To understand the dynamical of the system, or to understand unlock the behavior of the system dynamically, what you have to first define the dimensionless variables. Now you have to first understand what is the dimension of like field phi, the phi dot, the t, and all these things, and based on this we have constructed the x, y, and lambda. Now this x is the derivative of the field, time derivative of the field, y is proportional to the v phi, and lambda is v comma phi over v. So it is the first derivative of the potential. What I'm going to do is that I don't want to consider any form of potential. So can I study without as a general approach? So for that, again, what you have to do is that you have to first construct the autonomous system, and to do that you have to take the derivative of these variables x, y, and lambda. So when we are taking the derivative like dx over dt, but here we have converted dt as h dt, and this h dt is known as dn, and this n is equal to log of a, hence it is also called as the e-fold, number of e-folds, which is has been specified to study the inflation. So if I'm seeing the structure of x prime, y prime, and lambda prime, we are understanding that in x prime it is proportional to x, lambda, and y. So it is good. So if we have this lambda, then again we have to find that what could be the characteristic of this lambda. If lambda is now a constant, then this two-dimensional equation is fine to describe everything. But we are seeing that lambda is not constant because lambda is minus v comma phi over v to the power 3 by 2. Therefore I have to take again the derivative of the lambda, and we found that again we will encounter with the second derivative. So here we have gamma. Now the problem is that gamma has that second derivative in the potential. Okay, therefore gamma is not a constant quantity. So now because we are not taking any specific form of gamma, therefore we cannot say that it is the constant, or we don't know exactly what is gamma. So to carry out this three-dimensional thing, either you just again take gamma prime. So if you will take again gamma prime, then again you will have the third derivative of the potential. It will go on. So therefore we have to somewhere stop it. So what you can do is that either you define what is the form of gamma, or what you can do is that you take just gamma as a constant. So I'm just coming. So therefore if you are working with general kind of potential, then there is a limit. Now as we have defined our autonomous system, the next job is to find the critical point of the system. Okay, and this critical point of the system can be find out by x prime, y prime, lambda prime to be 0. So if it is 0, then you will get the algebraic equations, and we have the three equations. Okay, so therefore we will get the three critical points and so on. So number of critical points can vary. Okay, so now here we can say that lambda prime can be equal to 0 if your lambda is 0, x is 0, y is 0. So if your lambda is 0, it does only tell you that this v phi is 0, which makes that v is constant. So again, it is not a very amazing thing. So it will become a trivial solution. On the other hand, x is 0, there is no field, y is 0, then potential is now again to be 0. What we can do is that gamma to be 3 by 2. So if we are fixing the gamma 3 by 2, so now the gamma has only constant kind of characteristic. Okay, but if you don't want to work with the thing, then what you can do is that you can assume the gamma something. Again, what you are doing is that you are indirectly specifying the potential. So if you are specifying any potential form, then again you can easily calculate lambda, and you can easily calculate y. So either you start with v phi and then find gamma, or either you start with gamma and then y. So you are fixing the potential. So it will not going to be work. So what we are going to do is that we are going to adopt some different technique that we are going to talk about. Okay, so now as you have finished with critical point, the next work you have to do is that you have to find the stability of these critical points. So how will you do it? What you can do is that you take these equations and then you linearize it. Means that you do the Taylor series expansion of this thing. Now to do that, what you can do is that you can construct a Jacobian matrix which will look like that x prime over dx, dx prime over dy, dx prime over d lambda. Okay, and so on for dy prime and d lambda prime. Okay, so if we are getting 3 cross 3 Jacobian matrix, and then you are evaluating this derivative around these critical points, and after that what you have to do is that you have to find the eigenvalue of this Jacobian matrix. Now since it's a 3 cross 3 matrix, therefore you will get the 3 eigenvalues, and depending on the real part of this, because this eigenvalue can be complex or maybe some real. So if the real part is carrying the negative signature all around, okay, then we are saying that we can call the critical point is stable. If you have alternate sign, then it is the saddle, means that the point will at some point the point is kind of an attractor one, and then after some point it will acting like a repeller one. Okay, And if all the real part has the positive signature, then the critical point will become completely unstable. Okay. So we understand the difficulty of this system. We have to specify potential. Now the things that people have already carried out, that gamma could be some model and so on, they have already studied, or maybe gamma have one particular value 3/2. They have studied and they found some different dynamics. Now, how can we bypass this technique, and can we omit this autonomous system? Well, we can do it. I have already specified you that lambda CDM model is corresponds to study the dark energy and with dark matter, and from here we understand that this is the standard model of the cosmology, and it is exhibiting all the observations so far we have. Okay, but the thing is that this lambda cannot be only just constant. Okay, so maybe it has more dynamical feature, and to understand the dynamical feature, we define that this dark energy is composed of some dynamical fluid, and obviously this fluid has some kind of pressure and the energy density, so we can always define the omega. Now if it is composed with only lambda, then it is always a -1, but we want to understand that is dark energy dynamical or not. We say that omega is depending on either time, either n, or either only scale factor. And what you do is that you take the Taylor expansion of this around today, like what is the equation of state today, and then you can have 1 minus a to the power omega 1. Omega 1 is again a one constant, and maybe it is only a at 1 minus a, depend. So what we have done here is that now, since in our dynamical system the independent variable is dn or log a, so we have taken the Taylor series expansion, and the explicit variable is n, omega of n up to first order -1 plus omega 1 into n. So you assume that this is corresponds to the -1 today, and then there may be some kind of deviation or not, we want to see. And secondly, we have the phenomenological approach, that suppose we have the EOS which is time dependent. We have the two constant omega 0 and omega 1. It can be fixed to -1, but we are not fixing it. And apart from it, it is depending on the Hubble parameter. There is a time, cosmic time, Hubble parameter h, and the derivative of the Hubble parameter. Now, if your h is constant, then again this total thing will be 0, and then you are going to get omega t is omega 0, which is again the lambda CDM cosmology if omega 0 is -1. Okay. Now, what is this? So we understand we have parameterized our equation of state, and we already know that our tachyon field is again having the equation of state, which is x square minus 1. So these things are same, therefore we can equate it. So here, from here we understand what is x and in terms of n, but we don't require in n. Therefore what we can do is that we can take the derivative. So here I have already shown you that we are taking the derivative and they are equal. So from here we are constraining our x prime. So we will directly from this observation we can have one of the autonomous equation x prime. Now equating this x prime to this one x prime, so from here we can eliminate lambda. So lambda now can be depend on x and y. With this help, what we can do, what we have done is that now we do not require this equation. So from the observation we have the new autonomous system. We have written lambda in terms of xy, which is also dependent on omega 0 and omega 1, and from here we can construct x prime and y prime. So now we have eliminated the gamma. We can also understand gamma just by taking lambda prime, and from here we can easily find what is the gamma. Okay, so in some sense our three-dimensional autonomous system has now reduced to two-dimensional autonomous system. Okay, so this is the very interesting thing. So what we have done is that now we don't require lambda, because lambda is again represented in x and y. X prime and y prime are the new autonomous system. Everything is fine. So the dynamics of x and y will going to decide what could be the lambda. Okay, so now we are not required to choose any kind of potential, and neither we need to choose any kind of gamma. So in this way it is more abstract, and with this parameterization we are directly working with the data, because we understand what is the contribution of this thing. From lambda CDM model we know where the omega 1 will lie, omega 0 will lie, and omega 1 will lie. Okay, so from here we are going to evaluate everything depending on omega 0 and omega 1. So the critical point will depend on omega 0 and omega 1. So first we are going to use the first parameterization, and for the first parameterization we get only one critical point. Okay, now by seeing the phase space parameters, you may wonder that what is this? Basically this phase space is constant, because the phase space can be from -infinity to infinity, but from the structure of tachyon field we understand that the x, because of the square root phenomena, this square root 1 minus phi dot square, it has upper and lower limit. So x is corresponds to phi dot, so x cannot exceed between plus and -1. Okay, so if x is constant, in some sense y is also constant, therefore we are only strict with 0 and 1. But one can also say that, okay, we can also get into the negative direction, but because of some difficulties of the technicalities corresponds to the first parameterization, we have to use the separate study. On the other hand, whatever, so this field cannot cross the x negative thing. So if you want to use the negative of x, we have to study separately. So this thing, whatever we are using, we can choose to work with x and y having some kind of positive thing. Okay, now if I am to, my critical point is depending on omega 1, and there is a white region as well as the green region. This green region showing you the accelerating region where your omega total, that the whole system can be in acceleration if you have -1 to -1/3. So green region is separating, showing the accelerating region. On the other hand, this P1 is non-accelerating region, and when we have evaluated, we found that this at this critical point the omega total is came out to be 0. So again, it is showing you the matter phase of the universe. Okay, so if I am setting omega 1 to be positive, what I have found that all the vector fields originating from some x0 and y something, so everything is basically attracting towards P1, which shows that P1 is now your stable point, but it is showing you the non-accelerating kind of characteristic. Therefore it cannot be the physically observed, it is no longer a physically observed thing, because our universe is accelerating, not it is going towards the matter dominated epoch. So this is physically not possible. On the other hand, if you are assuming omega 1 to be negative, then all the vector fields which is originating from this P1, so okay, it is fine, and some of the vector fields is going towards this green region. So again, it is very fine. But when we have tried to find out that what is the how the green region looks like, what is the stability of the green region, so to find out that, we have solved x prime y prime numerically by solving the differential equation with some initial conditions. We found that as n is negative is showing you the early time. So at early time, the universe is starting from sigma omega m, which is the dark matter density is 1 or dominated. On the other hand, the field density is less dominated, so we can say that we are in the matter regime. Now as the system evolves, the dark matter density decreases and the tachyon density increases, and when it is in peak, the omega total is now going towards negative thing. So we say that, okay, this tachyon field is basically generating the negative pressure and acting like a dark energy. But what happens is that as the system again evolves, we are seeing that this dark energy or tachyon field density is decreasing, and again sigma square is contributing. So in some sense, it is creating some kind of problem that no, it is not possible. Therefore, we are saying that if your omega is negative, again your green region is not stable. Therefore, it is not physically viable. So yeah, if we are choosing the first Taylor series expansion, Taylor series parameterization of equation of a state, this is not very give you the fruitful result. And this green region can be stable only when your omega 1 is equal to 0. So all the vector fields will converge towards the omega 1 is equal to 0, means that it will converge towards -1, and basically it is again the same thing like lambda CDM model. So tachyon is again behaving like constant dark energy model, so we don't require it, because we want to try to find the deviation of that, how the tachyon field can be more deviation, can show the more deviation rich in dynamics from the lambda CDM model. Okay, so therefore we can safely say that this parameterization, the Taylor series expansion, will not work. So on the other hand, if you will see the second parameterization, okay, let's come to the second parameterization. We have drawn the phase space. Again, the phase space is compact using the omega phi to be 0 to 1. Okay, but here we are seeing 4 critical points, where one critical point having x0, y0, one of the critical point is x0 but y is 1, one of the critical point is depend on omega 0 and also omega 1, and here also omega 0, omega 1. So this critical point is more interesting because it is now giving you omega total to be 0, which is acting like a dark matter kind of scenario, and P2 is showing in the green region there will be an accelerating kind of thing. The vector fields are coming towards P1, towards the dark matter kind of thing, and again then it is repelled towards the accelerating point. It shows that it is exhibiting the same kind of dynamics, resembles the dark energy and dark matter kind of scenario, that the universe is going through some kind of matter phase and then entering towards the accelerating phase. Okay, so depending on the choice of omega 0 and omega 1, we can have the point, maybe it will shift towards here, and if in P3 x is 0 and y is 1, which is actually again giving you as a constant kind of scenario, the lambda CDM model. Okay, so besides besides this, what we can understand that when omega 0 is not -1 and omega 1 is not 0, then we have the very dynamical kind of picture which was absent in the previous equations. Okay, So we try to understand this aspect from the evolution of some cosmological parameters. So again, we solved that autonomous system and we found the evolution of omega total, some kind of sound speed, omega density of a scalar field, the fluid density, and then we have the gamma and we have the lambda, and these gamma and lambda are the constant of the potentials. Now, what we are seeing here, we are seeing that our universe at the early time where you have the matter density, and matter density is dominated here. And at this point, your omega phi scalar field is not dominated. Here, omega total is starting from 0. It's actually hinting us that it is corresponds to the matter dominated phase. Now, because in our system there is no radiation fluid, therefore there is no radiation kind of solution. Now, during this phase, the potential parameters are kind of very steep, and so that the tachyon field will be rolling towards some kind of stable thing. Now, as the system evolves, omega phi is going to be dominant. Sigma square or the fluid density becomes 0, and here we can see that omega total is converging towards of -1. Now, during the whole analysis there is a sound speed. The sound speed is a very interesting thing, which is basically described if you are using the perturbed phase, that our background is not homogeneous and isotropic, but it has some perturbation. So in the non-canonical field, these perturbations is the change in pressure with respect to the canonical system px and the energy density of rho x. Well, sound speed is always 0 with the fluid because it is not dependent on x, but the fluid has some kind of thing, okay? And it turns out that the tachyon field has always speed, the sound speed, or whatever the perturbation is generating in the field will always travel with speed of light, okay? So cs square always be 0 to 1, okay? It cannot exceed 0 to 1 to have the stable kind of field. So we understand that this the characteristic of these cosmological parameters is happen to similar kind of effect of the way the universe has expanded and entered in the dark kind of regime. Now, so far using the parameterization technique, we have omitted the lambda, and from here we understand what is the lambda, and also we have found out that what is the gamma. So we have carried out without the need of any potential. Therefore, in some sense, what we got that to study this kind of behavior, we should not only depend on from the potential. We can directly use the observational evidence, and from there we can easily work out the complete detail that how the field will behave. And this kind of technique can be used any kind of scenario, any kind of scalar field. Now, one can also consider the potential of this thing, because you have the lambda, we have the lambda, and from here we understand what is the v phi. So from the omega total, you have -2h dot by 3h square minus 1. Okay. So again, this is the differential equation. Omega total, we know what is the solution of omega total. It's look like this one. And from here we know the solution of h. We know the x lambda. So from here we can easily construct v phi. So the true v phi is denoted in the denoted by green color, and the rest of these colors like black and the red color is showing the approximate function, that what could be the functional form which can fit this data. And what we are finding is that this red color is corresponding to a minus exponential functions, and the black one is that 1 over phi square. Okay, so these are approximate, but we have already shown you that we do not require to understand what could be the potential. Okay, so the conclusion is that this method allows us to directly work with observational data to predict the system's stability. The method in general can be applied to any scalar field to construct the potential. For the Taylor series expansion of the EOS, the behavior of the field closely resembles lambda CDM model. Any deviation to this, the system renders non-physical solution. However, in the latter case, the behavior is more dynamic, as we have already seen. Unlike other scalar fields, like quintessence, the tachyon field is sensitive to the choice of parameterization, because we have also worked out different, because there exist so many other parameterization. Okay, some parameterization is a power law type of parameterization, some have logarithm type of parameterization, but when we are invoking the tachyon field in the way we want to study, then there was an issue of critical points, that we could not get any kind of critical points. And if the system has some kind of critical point, the Jacobian does not exist, means that the derivative becomes divergent, okay, at those critical points. So therefore, the tachyon field is not compatible with all the classes of EOS, which says that although we have the large pool of potential, but using the EOS, we can narrow it down, and we can have the dynamics which is very much observationally constrained dynamics. So I hope so far you have so there are so many literatures, you can go through these literatures to understand that what are these. So there was a person who has already reconstructing the dark energy potential. So he has used the quintessence field to reconstruct the potential of the quintessence field. Again, he has worked out with the data. So some person has used the power law, inverse law, to understand the cosmology of tachyon. Again, there is a very nice thing in this paper, like what is needed of a tachyon if it is to be a dark energy. So dark energy is they have already studied this with without assuming any form of a potential by three-dimensional autonomous system, x prime, y prime, and lambda prime. And they have also encountered with presented the interesting dynamics corresponds to Tachyon field. We have different literatures you can go through. So I hope you like this video, and if you like this video, please share to your friends. And if you have any doubt, you can text me, you can email me, and so on. So thank you very much. This is Ananda Cap signing out.